Alright, today we're going to be looking at section 4.3, polynomial division, the remainder theorem, and the factor theorem. We got 4 objectives. We're going to perform long division with polynomials, determine whether one is a factor of another. We're going to use synthetic division to divide polynomials. We're going to use the remainder theorem to find a function value f of c. And then we're going to use the factor theorem to determine whether x minus c is a factor of f of x. So this is what I was using before to find function values. So we're going to go through it in depth in this section. So here they're showing you some linear factors of a polynomial here. Once it's factored out, showing you the zeros. And this is going through how to determine whether a linear factor is a factor of a polynomial. So you start with your polynomial, which is the dividend, and then your factor, which is going to be the divisor. And if your quotient comes out equal with no remainder, then it will divide evenly. The process is you take your first term and you're going to focus on this first term. I want to know what factor do I need to multiply x by so that it becomes x cubed, and that will be x squared. So that's how this term comes to play. You will then multiply both terms by x squared. This will become an x to the third. It should always match up. That will become just a x squared. And then you would change signs and subtract. So that's why right now it's showing a plus, but they change sign, subtract, and then that's why you go from 2x squared to just x squared, because you got to subtract it, or change the signs, whatever the signs will be. Sometimes it'll be a minus and you change it to a positive. I'll go through this in depth when I start working examples, but they're going to do that continually for each value, and then they end up with a remainder of 0, so we know that that will be a factor. So they show a few examples. Whenever they break it down into like algebraic terms, the px stands for like the polynomial, that's the dividend. Dx is what you divide it by times the quotient plus the remainder, that should equal to the original polynomial. Then we're going to look at the remainder theorem. Okay, so if a number c is substituted in for a polynomial f of x, then the result f of c. So if you were to plug some number in, f of c is the remainder that would be obtained by dividing f of c by some constant. So this is remainder theorem. Again, it's kind of hard to understand when reading, but I will show you exactly what that means. I think we also did this in the previous section when I was working those problems, whenever we plugged in a value, and then I did synthetic division to show you that that was equal to the same. Here again are a couple examples going through long division, looking at the remainder, and then they also plug it in just with the coefficients. And then we start talking about synthetic division, so that is using just the 0, putting in what we call a box, and then going through that process. First number comes straight down, multiply below the line, write the result, add or subtract, and then continue to multiply every number below the line by 2, or whatever your box number is, and then combine like terms until you get to the end. So here's examples of synthetic division, but again, there's a lot more to the process, so I'll explain that as we get there. You need to check to make sure you have all your terms. So when you're checking for your terms, whatever is the largest exponent, that determines how many terms you should have. So we have a 5, so we got to count down in order. So 5, 4, 3, 2. We're missing the single x value, or this is 1, and then we have 0, the constant term. In this problem, we have an x to the 4th, so we should have a 4, 3, 2, 1, 0. We're missing some terms, so you would have to put zeros as placeholders where those constants would be. So they're spelling that out for you right here. Writing zeros for missing terms. That is a big part of long division and synthetic division to make sure everything lines up correctly. the factor theorem. So for a polynomial f of x, if f of c is equal to 0, then x minus c is a factor. And then they show you plugging it in, you get 0, and then doing the same thing with synthetic division. And then that ends the section. So we're going to jump into my math lab and actually do some examples.